So students, welcome back to this video session. In this session we will see what is a task, what is a process, and what is a threads. So in the last session we have seen operating system basics. So in this session we will see task, process and threads. So the term task, process, threads with respect to operating system context is the work done. It is the amount of work done. It indicates the amount of work done. Now, amount of work done by whom? The amount of work done by CPU. The amount of work done by CPU. That is called as task, or that is called as process, or that is called as threads also. So, here you see the task refers to something needs to be done. Task defined as the program in execution and related information is maintained by the operating system. It is also sometimes known as job. Program or a part of the program is in execution is also called as a process. So process is nothing but the program which is dumped into the main memory or a part of the program. Why it is a part of the program? Sometimes program may be lengthy. Because of the restriction in the memory, you cannot dump the entire program into the memory. That time part of the program is dumped into the memory. That's why process, that time also that part of the program which is in execution is called as a process. So students, please remember, process is an active entity. Process is an active entity. But program is a passive entity stored in the form of file in the disk. I repeat, process is an active entity. Process is an active entity. Program is a passive entity stored in the form of file in the disk. So the term task, job and process refers to the same entity in the operating system context. Now, the process is a program or a part of the program. It is also known as a passive active entity. The process is also known as an instance of the program in execution. Why instance of the program? It is called an instance. What do you mean by instance? Suppose you write the program, you execute that program. You can execute that program in several times. You can make the copy of the same program. Then that's why process is called the instance of the program. So when you execute the particular program, that is a process. When you dump that particular code in the memory, which is in execution stage, that is a process. And if you execute the same copy of the program, then it is an instance of the program. The process is called as an instance of the program. So process requires various resources. First of all, first resource is CPU. The first resource is CPU. Without CPU, because CPU should be allocated to the process for the execution. After that, it requires input-output device, memory, all those things it requires. The structure of process, concept of process leads to concurrent execution of task. That means there are more than one process can run in the CPU for the better utilization of the CPU. For example, you think like there are four processes are running. Think like that, four processes. Process 1, process 2, process 3 and process 4. So when process 1 is running, it needs some IO device and it will go to the wait state for IO device. That time process 2, the CPU will switch over from this process to this process so that it can make utilization. CPU can be utilized properly. So when the first process is in a waiting state, then CPU will switch over to the other process. That is called as efficient utilization of the CPU and other system resources. I hope you understood. So next one is, normally process mimics a processor. Very important point. Process mimics a processor. I told you inside a process there is something called as process control block. What is a process control block? Process control block holds the information about the process. What information it holds? So you see, this is the process. this process holds the information about status register, working register, stack pointers and program counter. You know, program counter points to the next instruction to be executed in the memory. Next instruction to be executed in the memory. So when you see this process address space, it has got all the components of the processor. It has got all the components of the processor. That's why the word process mimics the processor. Processor contains register, processor contains program counter, processor contains stack pointer, processor contains working register, processor contains. Same thing is there in the process also. So that's why process is mimics the processor. You can call process is a virtual processor. Now this is the address space of the process. When you load the process into the memory, the address space looks like this. Process has got its own code memory, process has got its own data memory, process and data memory grows in this direction, stack memory grows in this direction. See, process has got its own stack memory. Other than stack memory, one more memory is there, that is called as heap memory, heap memory. So four types of memories are there in the process: code memory, data memory, stack memory, heap memory. Heap memory is used, code memory is used for storing code and related instruction. Data memories are used for storing data, and stack memories are used for storing like temporary variables and return address when you call the function. And heap memory is used for dynamic memory allocation purpose. So this is the information about the memory organization of the process. So as I said, process which will inherits all the properties of the CPU. Like when the process is loaded into the memory, then the register, program counter register, all are mapped to the physical register of the CPU. I told you, like in the previous slide, process contains all these different registers, program counter, etc. When you load the process into the memory, all these registers are mapped to the physical register. All these registers are mapped to the physical register of the processor. Clear? Then other than that, there are three memory sections in the process can use. One is the stack memory, which holds the temporary data, data memory which holds the global data, and code memory which contains the program code and corresponding program code instruction corresponding to the process. So one loading process, listen here all of you, one loading process into the main memory, specific area of the memory is allocated for the process. Clear? One loading process into the main memory, specific area of the memory is allocated to the process. Now, what do you mean by process state and state transition, or what is a process life cycle? See, when you create the process, from creation till termination, process will get changes, process will traverse through a series of states during this transition from the creation state to the termination state, and this cycle is known as process life cycle. So process life cycle. So what is a process life cycle? Process life cycle is the number of states through which process transits during the starting from creation to the termination stage. That is called as a process life cycle. Now here you can see the state transition of the process. This is a diagram indicates the state transition of the process. So we have here, this represents the state where the process is created. When the process is created, this is represented by created state. After that, once you load the process into the memory, that is incepted into the memory, then process will transit from created state to the ready state. So, and it will wait in the ready state. So it will wait for the CPU for the allocation. CPU has to be allocated for the processor. So when the CPU is allocated for the processor, then CPU will be allocated by the scheduler. There will be several scheduling algorithm that will allocate the CPU to the processor. The processor will move from ready state to the running state. The processor will move from ready state to the running state. So in the running state, so either process can complete the task. If it completes a task, then it will move into the completed state. When it executes complete the execution, it will move into the completed state. Otherwise, if there is any interrupt, then preempted, or if there is any interrupted, if the CPU is interrupted or preempted, then process may go back to the ready state and wait for the CPU allocation. In the running state, if the process wants some IO device, and then it will wait for the IO device, and that state is called a blocked state. If it gets IO device or resource, then it will complete the related IO task and it will move from the block state to ready state and wait once again for the CPU allocation. So this is the state transition of the process. So in the next diagram you can see here, as I explained, there are created state, ready state and running state. Created state at which process is being created, ready state at which process is inserted into the memory, running state where in the source code instruction corresponding the process is being executed. Other than that, we have block state, it is waiting for the IO device, and completed state where the process completes its execution. Like thread is a primitive that can execute a code. Thread is a single flow of control within the process. A thread is also known as lightweight process. So thread is a single sequential flow of control within the process. Thread is also known as lightweight process. Now student listen, thread is a lightweight process and lightweight and process is a heavyweight. That doesn't mean this process is 100 kg, thread is 10 kg, not like that. Process is a heavy weight or bulkier, means when the process is created, so then the process has to be allocated with its own memory space, its own address space for register, stack register, data stack memory, data memory, heap memory and code memory. But thread, when you create the thread, normally thread will be created inside the process, and when you create the thread, it will share the same memory space. All the threads will share the same memory space. No separate memory is required for the thread. But when you create the process, separate address space is required. Separate address space is required. That is the important difference between thread and process. Process needs a separate address space. For example, if I create 100 instance of the process, if I copy 100, process is nothing but instance of the program, right? Process is nothing but instance of the program. If I create 100 instance, I need 100 address space for the process. Each address space should consist data memory, code memory, heap memory, stack memory. That's why process are heavyweight. But threads, when you create a thread, it is a lightweight. It will share the same process memory. So student, you see here different threads. So now inside the process, for example, this is the one. So think like this is the one process. Sorry, this is the one process. Inside the one process, I have several threads. So what I can do is I can assign one thread to some part of the program, one more thread to the execute some part of the program, one more thread I can execute to the assign to execute to the some part of the program. But all these threads are sharing same address space. That is a difference. Now, but there is a small changes here. Small, it will share same data memory and code memory, but there will be a separate stack memory for the each thread. For the each thread, separate stack memory. Why? The question comes why? I will explain you. I will explain you that in the next slide. Each thread will use separate stack memory. Each thread will use separate stack memory, but it will share the code memory and data memory, if memory. Now you will come to know that one in the next slide. So here you can see we have the process. Inside the process we have thread 1, thread 2, we have thread 1, thread 2, thread 3. But you see all these thread 1, thread 2, thread 3 are sharing the same memory, code memory, data memory. But there is separate stack memory for the thread 1, separate stack memory for the thread 2, separate stack memory for the thread 3. Why? Because when you call the function, then the return address, for example, from this thread 1 I will call one function. That time return address should be stored in the stack. So if you use the common stack, then return address will be get overlapped. That's why separate stack is used. Separate stack is used for the thread 1, thread 2, thread 3. Other than that, this thread 1, thread 2, thread 3 uses same code memory and data memory, and all are running in the same process address space. That means all the threads are running in the single process address space, and they are sharing the single process address space. And here you are running multiple threads, and this concept is called as multi-threading. The process is split into multiple threads, which executes a portion of the process is known as multi-threading. So what is the use of multi-threading? Multi-threading, the advantage of the multi-threading is better memory utilization. What do you mean by better memory utilization? Like multi-threads of the same process share the address space for the data memory. Like here, even though there is multiple threads, all these threads will share same memory. That's why memory utilization will be done properly. Other than that, CPU utilization, because CPU utilization in the sense like if the one thread is executing, other threads can execute simultaneously, or if the one thread is in the wait state, other thread then CPU can switch from one thread to the other thread. CPU can switch from one thread to the other thread without loading separate address space. Try to understand. When CPU switches from one thread to other thread, it need not load a separate address space. It can use the same address space. So switching from one thread to other thread is faster. But when you switch from one process to other process, it is not faster. Yake? When you switch from one process to other process, it has to dump it has to create the address space. CPU has to allocate the address space for that process. So that is a separate, it requires additional memory. So process switching is not faster, but thread switching is faster. Student, try to understand. Thread switching is faster, and it will make the efficient CPU utilization. So efficient CPU utilization. Now students, now we'll move to the thread standards. So there are different standards in the thread also. Means the thread creation has to follow, when you create a thread, you need to follow certain standards. Means thread programming, multi-thread programming has to follow some standards. One standard is a POSIX threads. Second one is a Win32 threads. Third one is Java threads. What is this POSIX thread? POSIX thread, the full form is POSIX stands for Portable Operating System Interface. So actually, from the origin of Unix operating system till now, different types of variants of Unix operating system came into the picture. But the programmer who use Unix operating system, they have one problem, like it is like whatever program they write for one version will not work on the other version properly. That is because there is no standard. So that's why IEEE committee, they came with standard, and that standard is known as POSIX. So POSIX, in the POSIX also different substandards are there. POSIX 1.1, 1.2, 1.3, POSIX 0.4, something like that. So POSIX 0.4 standards deals with the real-time extension, and POSIX 4.8 deals with the thread extension. So POSIX is the standard library for thread creation and management, and it is called as p-threads. So in the Unix operating system, you can use the p-threads, and you can write the API that will work on different variants of the Unix. Similarly, we have something called as Win32 threads. Win32 threads are the threads supported by various flavors of the Windows operating system. Win32 application programming interface library provides the standard set of Win32 thread. So Win32 thread for the creation and management functions. Similarly, we have Java threads. Java threads are the threads supported by the Java programming language. Java thread class thread is defined in a package java.lang. So you can use Java threads also. So now, thread preemption. What do you mean by thread preemption? Thread preemption is nothing but it is the act of preempting currently running thread. Like means you temporarily you are going to kill that thread. That is called as a thread preemption. Why thread preemption is is very important? Because sometimes some thread misbehaves that CPU has to, or operating system has to kill that thread or process. That is called as a preemption. So it is performed for sharing CPU time along with all threads, because some thread, CPU has been allocated to the certain thread, and the certain thread misbehaves. It will not hand over the control. That time they necessary for sharing the CPU time among all threads. That time you need to preempt the particular thread. So execution switching among threads are known as thread context switching. We have process context switching and we have thread context switching. Process context switching are slower, but thread context switching, switching from one thread to other thread, are faster. There are two types. One is called as user level thread. So user level threads are the programs runs in the user space. They don't have kernel permission. They exist in only running process. Other than that, we have something called as kernel level thread or system level thread. All these are run in the kernel's address space with certain privilege, operating system privilege or kernel privilege. There are many ways to bind a user level thread to kernel level thread. One is many to one model or one to one model and many to one model. So these are the different types of binding user level thread to kernel level thread. So what is the difference between thread and process? So now we'll see thread is a single unit of execution and part of the process. Thread lies inside the process container. Process is a container for thread. Process is a program execution and contains one or more threads. Thread don't have own data memory and heap memory. Process has its own code memory, data memory, stack stack memory. Of course, thread has got their own stack memory. Thread cannot live independently without process. Process contains at least one thread. Then other than that, there can be multiple threads in a process, and threads within the process share the code, data and heap memory, as I explained. Threads are very inexpensive to create because it will share the same memory space, so it's inexpensive. Processes are very expensive because it needs a separate address space. Content switching is inexpensive and faster in the thread. Like when the CPU switches from one thread to other thread, it is called as context switching. That is faster because Very easy. But content switching is a complex, involves lots of OS overheads in the process, because process has to create a separate address space, and it is like complex process. So this is the difference between thread and process. Now, multiprocessing and multitasking. So what do you mean by multiprocessing and multitasking? Multiprocessing, the ability to execute multiple processes simultaneously, is called as multiprocessing. Systems which are capable of performing multiprocessing are known as multiprocessor. So you have seen the multiprocessor systems like Intel 5 different core, like single core, dual core, oct core, then pentacore, something like that. That's nothing but multiple processor that can be assigned to multi-processing task. This is also known as multi-programming. The ability of the operating system to have multiple programs in the memory is known as multi-programming. So here you see multitasking. Let me explain. All of you please concentrate. With that, I think after that we can wind up this one session. So here, let me zoom this one. So here, multitasking means more than one task. When the ability of the operating system to run more than one task or hold multiple processes in the memory, and it will switch from one switch the processor from one executing process to another process. And it is also called as a content switching. When the process CPU switches from one process to other process, it is known as a content switching. Content switching has got content saving and context retrieval. Content switching is nothing but moving from one process to other process, which contains context saving and context retrieval. Let me explain you this one here. Student, you see here, all of you please concentrate. Here we have process 1 here and process 2. Let us assume process 1 is running, and now process 1 wants to access some IO device. That time it will move to waiting state. So that time CPU will switch from process 1 to process 2. Immediately CPU will not switch from process 1 to process 2. You see here process 1 has stopped and it will move into waiting state, but process 2 in idle state, because when CPU switches from process 1 to process 2, it has to save process 1 details in PCB, process control block. It has to save. Then it has to retrieve process 2 details. Like you can see here, save the current context in the PCB and perform the operating system operation related to context switching. Like it has to switch from here to here, then reload the context of the process 2. For that it needs time. That's why this is the idle time where it will do context switching. After that it will go into running state. After some time you just think like CPU wants to switch from process 2 into process 1. That time also it will move into the waiting state, but immediately it will not switch over to process 1, because it has to reload. It has to store the process 2 context in PCB. Then it has to reload the process 1 context. After that only it will move into running. After that only process 1 will be in the running state. So this is the context switching. Other than that, we have something called as types of multitasking. What are the types of multitasking? We have 3 types of multitasking. One is called cooperative multitasking, and preemptive multitasking, and non-preemptive multitasking. In cooperative multitasking, there is no control. Like CPU is assigned to particular process till the process like return the control till it voluntarily returns the control or till the process completes its particular task, then other process has to wait. That is called as cooperative multitasking. In the cooperative multitasking, task process gets a chance to execute only when currently executing task process voluntarily gives the CPU. But in the preemptive multitasking, all the process gets equal chance to execute. Every process gets equal chance to execute. But what about non-preemptive multitasking? Non-preemptive multitasking is something like preemptive only. But here when the, for example, particular process it goes into waiting state or block state because it wants some IO. That time CPU can switch over from one process to other process. That means it will give chance to the other process. So this is a sort of non-preemptive only. But when the particular process goes into blocked or wait state, that time blocked or wait state, that time the other process will get chance. That is called as non-preemptive multitasking. That is called as non-preemptive multitasking. So with this we have completed process and threads. In the next class we will see task communication